premiumbeat.com.
Good morning, students. Avogadros Law, or the person behind this law, is Lorenzo Romano Amadeo Carlo Avogadro, wherein in 1811, Avogadro wrote in a paper that equal volumes of all gases kept at the same pressure and temperature contain the same number of molecules. Avogadro was the first to suggest that the volume of a gas is directly proportional to the number of moles of a gas present at the given temperature and pressure. Using the proportionality symbol, we can express the proportionality between the volume and the number of moles of a gas as volume is directly proportional to N at constant temperature and pressure. Mathematically, the Avogadro's hypothesis can be expressed as V over N is equal to K, where K is the proportionality constant. Avogadro's law can be expressed as V1 over N1 is equal to V2 over N2, or initial volume times the final number of moles of a gas is equal to the final volume times the initial number of moles of a gas. Okay, so let's now work on the Avogadro's law, which was expressed as V1 over N1 is equal to V2 over N2. So we can derive four formulas: one for V1, one for N1, one for V2, and another formula for N2. So how are you going to do it? You transform this formula by cross-multiplying. So that will now become V1 N2 is equal to V2 N1. So to start with, if you want to get the formula for V1, therefore, you have to eliminate N2 on this side. So, dividing this side with N2, that will be your denominator. Same with this side of the formula. Divide this side with N2, and you will be canceling this factor. Then, you will have the formula for V1 is equal to the product of V2 N1 over N2. Continuing, let's have your formula for N2. Your N2 will be or should be V2 N1 over V1. Okay? And then, let's start again with our working formula. V1 N2 is equal to V2 N1. This time, on the right side of the equation, we are going to eliminate one physical quantity. Let's say, eliminating N1 first. So, let's divide both sides with N1. So, this will be cancelled out. So, your formula for V2 will be, V1 N2 over N1. Our formula for N1 should be the product of V1 N2 over V2. So our four formulas, let's include the three other more formulas. This is for N1, this is for N2, for V1, and for V2. Let's try to apply the Avogadro's law in solving a sample problem. What will be the final volume of a 5 liter of helium gas which contains 0.965 mole at 30 degrees Celsius and 1 atmosphere if the amount of this gas is increased to 1.80 moles provided that the temperature and the pressure remains unchanged? So if you're going to look at the initial and final conditions from the problem, we have V1, initial volume is 5 liters. You have initial number of mole of the helium gas, which is 0.965 mole. The pressure is 1 atmosphere, which remained constant. Same as true with the temperature, which is also constant from the initial to final conditions at 30 degrees Celsius. So what happened here was the number of moles of the helium gas increased or was changed from 0.965 mole. At its final value, it became 1.80 mole. So we should expect that the final volume will also change. And most probably, from volume 1 of 5 liter, we can hypothesize already that volume 2 or final volume should increase as well. So since we're looking for V2, our formula will be the product of V1 and 2 over N1. So let's write it down. And then substitute. The initial value of the volume of the helium gas was 5 liters. Multiply it with the final number of moles of the helium gas, which is 1.80 mole. Dividing it, this product will be divided by the initial number of moles of the helium gas, which is 0.965 mole. So you're going to cancel this unit. The mole in the numerator cancels the mole in the denominator. And obviously, you need to multiply 5 to 1.80. And that product will be divided by 0.965. And your final answer is 9.3 liters. So, from V1 of 5 liter, our final volume now is 9.3 liter because the number of moles of the helium gas at first is 0.965 mole, and since it increased to a value of 1.80 mole, as we hypothesized a while ago, volume 2 must increase, and we were able to get an answer that is greater than the initial volume, which is 5 liter. So from 5 liter, our volume now became 9.3 liters. So Avogadros Law tells us the relationship between the number of moles of a gas to the volume of the gas, which is directly proportional to each other, wherein if the number of moles of the gas increases, the volume of the gas also increases. Or, if the number of moles of a gas decreases in its value, the volume of the gas will also decrease.